We're here at the Amplify Research Farm. We're going to install a GPS unit to get Jerry up and mapping. We'll see what, he's got a Case IH with a AFS universal display. We're going to plug in this Trimble 132 and see where we get to. So what we're looking at here is this. I was just talking with Josh. This is a little bit of a legacy device. This is a Trimble 132, but for what we're doing, this is actually a really good application for this unit, because it gives you the ability to get good signal, and for mapping, for the purposes what we're going to do, it works really well. Now, of course, it's not RTK. You can tell by looking at the screen here, we're dealing with a WAS setup. We're tracking 8 satellites, and then we're tracking WAS satellite 138, and we have a signal to noise ratio of 15. The G3D, basically what that means is we're only tracking GPS at this time, not differential. So when we get full signal here, there it goes. You can see it just kicked over to D3D. What that means is you now have a differentially corrected signal with 3D position. Your dilution of precision, or your DOP, is 3, and of course the lower that number is, the more accurate position you have. So it looks like we're in business here. So we just now need to turn on the Pro, or the Case AFS universal display, and see what we get. What we've done is we've configured the Trimble 132, and like I was telling Heather and Josh here, this is a ladder diagram that allows you to come in and basically get to configuration. We've come in and we've gone to output config, or port A config, and we've basically configured port A how Case asked it to be for the universal display, which is RTCM in and NEMA output. And we know we've got good signal as we go back out through the menus. Come on, takes 2 fingers to run this thing. You can see that we're tracking 8 satellites. We got a signal to noise ratio on the WAS at 15. And now I've gone in on the universal display up here in the cab, and under the menu setups, I basically set it up so that if we come in here under setup and we go to combine, and then we go to GPS receiver here, you can see that I've told it that it's installed. I've asked it to log data at a 1-second interval, and I've turned off the differential alarm so that when Jerry's running the machine, it doesn't continuously beep at him if he's losing WAS signal. Then I can come back out to the run screens, and by going to the GPS here, I can see now that signal's coming into the machine. I've got latitude, longitude, I've got an altitude, and I have basically all the signal I need. I got a full DGPS, 3 bars under DGPS. So that's really all it took. There was a cable that was present in this machine. If that cable hadn't have been in place, we would have had to get with the Case IH dealer or somebody like Ag Express and get that cable made and installed. But really, I think we got to clear some card here, and we can get Jerry. We'll do some checking of some components on his machine, and we'll get Jerry out there ready to map for us here on the Amplify Research Farm. This is a older style card that basically takes a PCMCIA reader, and so I actually have an older style laptop here that has the ability to read PCMCIA cards. So we're going to do that. We're going to clear it off, and so that Jerry can start anew here this fall of 2021. So basically what I have is there's your card reader. You slide her in there, and now that should, hopefully, the computer should recognize that it now has a card in it. You can see it does. And notice this is an older Windows XP machine. Maybe going over here in the shade might help, Heather. So if we come over here, and what we can see that on the card, there's actually a YLD file that's been created, and we're getting ready to go ahead and clear that off.
Is that the only way to clear this card, John?
It is. It is. Having an older, bigger card like this, that's the only way to do it.
There's not an adapter or anything, like sometimes you see like you can get an adapter and go that route.
Yep. So Luke's question is there another way to do it? I'll show you here in just a second, Luke. But your questions are really good. So I'm going to go ahead and I'm going to eject that card. Boom. And then I'm just going to go ahead and shut down the computer because we really don't need it anymore. But that's all it took. Now, Luke's question is what are some other options? And so in some of the newer machines, Luke, they've gone to USB jump drives. So they're moving data via a jump drive. But we're dealing with a legacy system, and so that's why the PCMCIA there's. Notice this is a 16 meg card. It's a pretty small card, and it's because of the firmware that this machine has, is that basically you know, it wasn't able with the operating system on the display to handle bigger units than that. I do have what you just talked about, right? I have another same style card, but it's adapted down to a CF card, and we could use this one except for, look at the size, 128 meg. Probably the firmware in the display up there isn't going to recognize 128 megs. It probably has to be something smaller like the 16 meg. And again, it just happens that we're dealing with some legacy equipment. Still works great. We can still calibrate this, still get good data out of it. It's just the screen and the firmware and that sort of thing is a few years old.
But that's the only way to
Yes.
clean the card.
See, if I had a, they call this a compact flash, right? CF card. If I had a 16 meg compact flash card, we could use this right here, and this is a lot more common to find in card readers, to be able to read a compact flash card versus the PCMCIA. So,
Okay.
so I had to dig out my old computer to be able to read the legacy stuff.
Cool.
So, and we're going to quickly take a look at the moisture sensor fin here on the monitor yield moisture or moisture sensor here. Just want to make sure that everything looks intact and it looks like it's in good shape. So hopefully I can get my wrench on this. It's a thumb screw, but it's pretty tight in there. I tried last time I was here and couldn't get it off. So okay. So Jerry was kind enough to clean it out for us first, so we didn't get a bunch of grain falling out of there. Now, this one is kind of tight getting it in and out of here because of the tailings elevator that's there. But basically what I'm checking here, and I probably don't need to take it out all the way, but what I'm checking is just to make sure that fin's in good shape. And I'm looking at this little copper dot down here because that's the temperature sensor. And I just wanted to make sure that moisture sensor is working, or it looks like it's in good shape and potentially is working. So how this thing works is it's like a capacitor. Charge builds up on this fin right here, and then what it's doing is timing how long it takes for that charge to discharge to the external housing, and that time is really related to the moisture of the grain. The wetter the grain, the quicker that discharge happens. The drier the grain, the slower that discharge happens. So it can basically estimate the moisture of the grain based on that capacitance reading. So that, we'll button her back up. We'll go up top and we'll take a look at the flow sensor. So what happens here is this is your clean grain elevator. It's basically the top side of what we were just looking at down at the moisture sensor. What's happening is paddles are coming up full with grain up here to the top of the clean grain elevator. They meet this shaft right here, and as that paddle comes over that shaft, it's basically throwing grain against our flow sensor here. And this is the flow sensor. When we're calibrating grain weight, we're basically teaching the computer how this thing measures the number of pounds of grain that are coming over the top. What we're getting ready to do is open it up, take a look at it, make sure that any deflector plate, if there is one in there, that it's in good shape, and then we're going to inspect the impact plate here on the flow sensor. So I will go ahead and open this up. It's 9/16, Jerry. No, it's 9/16. I started with the half, so we're in good shape. Try not to drop the tools and the nuts so that we don't have to go digging through the grain bin to get it out. And it's just a little bit too big, and that's a nylock nut there. So we don't want to lose that. And this is typically where I drop something and wish I didn't. So there we go. So take that off, leave that with it for now. As I pull this out, okay, so this is, again, this is an older impact plate, and Jerry, I think we ought to replace this. It's metal. I'm not so sure that at one point this didn't have poly on it, because what they were finding is when you get into tough beans, when it was just metal like this, it wanted to pick up the dust and the grime from the beans themselves. So they shortly after they came out, maybe, I don't know, sometime probably 2000 give or take, they actually started making these out of poly. So we get a poly plate, it gives it a little less stickiness. So yep. Well, if you can't get one, I know we can get one from Ag Leader, but we got, probably your dealer will have maybe this in stock. This is a pretty common machine, 2388. So that's why we look at these things, just to make sure what we got. And I'm pretty sure this was covered in poly, because they probably would have never left these Allen head bolts sticking out like that. They were buried in poly at one point. It's just, this has seen enough acres that the poly has worn itself off here. So that's basically why we look at this. And while you're at it, Jerry, there's an impact, or there's a deflector plate that what it does is it closes the gap between the top of the clean grain elevator and the paddles, and it sits right in here. You may ask him if you can get one of those too, because as I reach back in here and I feel that deflector plate, what I'm feeling is ripples. Okay. I'm feeling that it's worn enough.
The rain's getting it worn in.
Exactly, so it kind of goes like this. And again, that's going to affect how that grain comes over the top and hits this impact plate. We want that to be as consistent as possible. That's why they put that deflector plate in there, is to basically keep that grain on the paddle as long as it can. Otherwise, that grain was coming up, being thrown against the top, and then reflecting back, bouncing down, and not giving as consistent of a reading. So that deflector plate, it'll work. It doesn't have holes. I've been in installations where there's actually holes in that thing. So this is just a matter of it's worn. It will get holes in it eventually, but as long as you're in here and you're going to do some replacement, probably this impact plate and that deflector plate could be replaced. So other than that, it looks pretty good. When we used to do these installs, instead of the moisture sensor being down on the clean grain elevator like it is in a bypass, they used to have us mount them right here. We cut a hole here, cut out flighting, re-weld flighting, and stick your moisture sensor right here. Well, guess what comes up right there over the bottom of this bubble up auger is all the gunk. And so that moisture sensor would get all gunked up. So after the first couple of years, they developed that bypass unit, which really works well. So we'll button this back up, and then we'll see how Josh is doing. We should be good to go. So for some of you, you probably have heard the calibration talk that I've done in terms of how this engineering behind this system works. And I was just having a conversation with Jerry, and I pointed out that basically this is the load cell that when you're calibrating, what you're doing is you're teaching the computer how to take millivolt readings out of this load cell that are proportional to the amount of grain hitting it. So it's basically measuring the number of pounds of force here, putting out a millivolt output, and then the computer or the calibration system is actually then turning that millivolt output into pounds. So this is the critical part, is why you want to change flows, or why you want to calibrate with multiple flows, is that you are simulating light pressure against this plate as in low yield, or heavy pressure against this plate as in high yield. And so you basically step up your flow rates as you go through for calibration.